Hi, today we are going to discuss about quicksort method. Quicksort is a sorting algorithm which rearranges elements of an array in sorted order by picking an element as a pivot and divides the array into two partitions by placing the pivot in its correct position. Quicksort works on the principle of divide and conquer, breaking down the problem into smaller subproblems. There are mainly three steps in the algorithm. Step 1. Choose a pivot, that is, select an element from the array as a pivot element. Then step 2. Partition the array. Pivot element is fixed in its proper position by dividing the array into two partitions such that all elements smaller than pivot will be placed on its left and all elements greater than the pivot will be placed on its right. Step 3. Recursive calls. Repeat step 1 and step 2 on left partition and right partition till the partitions contains only one element. Let me explain this quicksort procedure using an example. Let us consider an unsorted array which is having 8 elements: 25, 57, 48, 37, 12, 92, 86, 33. The indices are from 0 to 7. The algorithm contains three steps. The first step is selecting a pivot element. So select first element as a pivot element. 25 is the pivot element. The second step is fix 25 in its proper position such that the array is divided into two partitions. All the elements less than 25 are placed in the left partition and all the elements greater than 25 are placed in right partition such that 25 is fixed in its proper position. What are the elements less than 25 in this array? 57 is not less, 48 is not less, 37 is not less, 12. Yes, 12 is less than 25. So place it in left array. Then is 92 less than 25? No. Is 86 less than 25? No. Is 33 less than 25? No. So the remaining elements, that is 57 is placed in right partition because it is greater than 25. Then 48 is greater than 25. Then 37 is greater than 28. Then 92 is greater than 25. Then 86 is greater than 25. Then 33 is greater than 25. So the array is divided into two partitions by fixing the partition in its proper position such that all the elements placed before 25 are less than pivot element and all the elements placed in right array are greater than pivot element. So see here, so 25 is fixed, left array, right array. So left there is only one element, right? There are many elements. All the elements that are placed in left side are less than pivot element. All the elements placed in right side are greater than pivot element. Anyway, the array is divided into two partitions. So this is left subarray and this is right subarray. Now we are going to repeat the same procedure on left side array and right side array till the partition contains only one element, because if a subarray or an array consisting of only one element, we treat that element is sorted. So here left side there is only one element, that is sorted. Now we are going to repeat the same procedure on right side of the array. See, by dividing the array, what is happening? 0 to 7 are there, the indices, and we are fixing a pivot element in its proper position. That is, assume that we are fixing the pivot element at position j such that it is partitioning the array into two partitions, dividing the array into two partitions, placing all the smaller elements before j and all the elements greater than pivot element after j, that is 0 to j minus 1 are arranged in left side, j plus 1 to n minus 1 are arranged in right side. We repeat the same procedure on left array and right array. Of course, here in the left array there is only one element. We treat that is as sorted array. And in right side there are some number of elements. We are going to rearrange them in the same procedure. Again, we fix pivot element by selecting pivot element. Say, in this right array, we assume that 57 is the pivot element and we try to fix it in its proper position. So 57 is fixed in its proper position and divide the array and rearrange the elements in left array and right array. 48 is less than 57, 37 is less than 57, 33 is less than 57. So three elements are placed left side 57 and 92 is greater than 57, 86 is greater than 57. So there are, see, 6 elements and 57 is fixed in its proper position such that the array is divided into two sub-arrays. Left array contains elements less than 57, right array contains elements greater than 57. So these 6 elements are divided like this. 57 is fixed in its proper position. Left side there is a partition, right side there is a partition. Left side partition contains values less than 57, right side partition contains value greater than 57. Now we repeat the same procedure on left array and right array. So we apply quicksort method on left array and we apply quicksort method on right array. So if you apply quicksort method on left array where you select 48 as your pivot element, first element of the partition. So 48 is the first element, we select it as pivot element and we fix it as pivot element and we select what are the elements smaller than 48. 37 is small and 33 is also small, so 37 and 33 are placed before 48 and there are no other elements, so right side there are no elements, so it contains left side there are two elements 37 and 33, 48. Then again this partition is, and we perform the same quicksort method on this partition. So 37, 33. We select 37 as pivot element and we fix that 37 by dividing the array into two arrays, left partition, right partition. What are the other elements? 33. 33 is less than 37, so it is placed in left side. Is there any other element? No, there are no other elements. So 33 is placed before 37. 37 is fixed as a pivot element in its proper position. And 33 is there in its left partition. There are no other elements in the right partition. So as there is only one element in the partition, we say that that is sorted. Then here there are two elements in the subpartition 92 and 86. We assume that the first element is pivot element. We fix this pivot element 92 by dividing the array into two partitions. All the elements that are less than 92 will be placed before 92. 86 is the element which is less than 92. So we place it in the left side. Is there any other element? No, there are no elements in the right side. Then in left side partition there is only one element. If there is only one element in the partition, we need not repeat the procedure because we treat this as a sorted element. So finally, see, the array contains 12, 25, 33, 37, 48, 57, 86, 92. It is a sorted array. So in this way, we can rearrange the elements of an unsorted array into sorted fashion by dividing the array, by selecting a pivot element, by fixing the pivot element in its proper position, by dividing the array into two partitions, left partition and right partition. Left partition contains elements less than pivot element, right partition contains elements greater than pivot element, and we repeat the same procedure on left partition and right partition as it is going to be divided further and further, and this dividing process will be repeated till the subarray contains only one element, because an array consisting of one element is said to be sorted order. Let me explain the quicksort method using the recursive algorithm. Quicksort is a recursive algorithm. It sorts the elements of array A. Low and high means the first position of the array and last position of the array. Low is the first position, high is the last position. A is the array. Normally low is 0, high is n minus 1. If the array contains more than one element, if low is less than high, then we have to partition it. Select a pivot element, then partition the array by fixing the pivot element in its proper position. So pivot element is fixed in its proper position and the array is divided into two sub-arrays, left array and right array. Pivot is fixed. Pivot is fixed and the array is divided into left array and the array is divided into right array. Now we have to repeat the same quicksort method on left array using quicksort method. Quicksort A low pivot location -1, that is pivot is fixed in its proper position, pivot location. Low to pivot location -1 is left array. Pivot location +1 and high is right array. So apply quicksort method on left array and apply quicksort method on right array. That is, we are fixing an element in its proper position, which makes left array and right array. That is left partition, right partition. Apply quicksort method on left partition. Apply quicksort method on right partition. The process is repeated till the array contains only one element. Now, let me explain this procedure using an example. How we perform partition, how we fix a pivot element in its proper position. The array contains 8 elements: 25, 57, 48, 37, 12, 92, 86, 33. Select first element as its pivot, then compare the remaining elements with pivot. And we need to rearrange the elements into two partitions, a left array, right array, and by fixing the pivot element in its proper position. Is 57 less than 25? No. Is 48 less than 25? No. Is 37 less than 25? No. Is 12 less than 25? Yes. So interchange next element of pivot with small element. So 12 is the smaller than pivot element. So next element of pivot is interchanged. So this becomes 12 and this becomes 57. Then swap pivot element and small element, 12, 25. See, 12, 25 remaining elements. So 25 is fixed in its proper position. Now compare remaining elements also. Is 92 less than 25? No. Is 86 less than 25? No. Is 33 less than 25? No. So 25 is pivot location. 25 is pivot and it is fixed at location 1. Now the array contains 12, 25, 48, 37, 57, 92, 86, 33. 25 is now pivot location. It is fixed in its proper position by dividing the array into two subarrays, left subarray, right subarray. So left array contains only one element. We feel that it is sorted. Now there is right subarray which is having 6 elements from position 2 to 7. We repeat the same procedure on right array. We repeat the same procedure on right array. So in this way we find the proper position of pivot element. We fix the proper position. We fix the pivot element in its proper position by dividing the array into two subarrays, left subarray, right subarray. If subarray is having more than one elements, we repeat the same procedure. Again, we pick one element as its pivot element. We fix it in its proper position by dividing the subarray again into two subarrays, and we repeat the same procedure. So this is a recursive procedure where we fix pivot into proper position. We perform quicksort on left array. We perform quicksort on right array. And this is the procedure of fixing a pivot element in its proper position. The only thing is we compare all the elements with pivot element. If any element is less than pivot element, they are getting interchanged like this. Two swaps will be performed to fix the element into its proper position. So if you practice the procedure, automatically you can get the information. Performance analysis of quicksort. Quicksort works on the principle of divide and conquer. The array is divided into two arrays by fixing the pivot element. Again, the subarrays will be divided to fix further elements. For example, an array of size n will be divided into two subarrays, each with a size of n by 2. Again, the array of size n by 2 will be divided into two subarrays, each with a size of n by 4, etc. etc. For example, if we consider an array consisting of 8 elements, assume that 8 elements are there in the array. It is divided into two subarrays where first array may contain 4 elements, the second array also contains 4 elements. Again, there is a possibility of dividing this left array into two subarrays, that is 2 elements and 2 elements. Again, this subarray is divided into one element and one element. Here also, this subarray is divided into one element and one element. Here the elements are four elements are there. This subarray is divided into two subarrays where each subarray contains two elements and two elements. Here these two elements are again divided into one element and one element. This subarray contains one element and this subarray also contains one element. And from here it is not possible to divide further because the subarray contains only one element. So how many times we have divided? Say 8 elements are divided into 4 one time, 4 elements are divided into 2 second time, 2 elements are divided into 1 third time. So an array consisting of 8 elements, maximum number of divisions are 3. In the same fashion, we have to find how many number of times an array can be divided if there are n number of elements. An array consisting of n number of elements. How many times we can divide means it is log n times. So an array consisting of n elements may be divided a maximum of log n times. Then what are the comparisons? The time complexity is directly proportional to comparisons. Here, after having the subarrays m times, so m is nothing but log n, m times where there are n number of elements of size 1. Thus, the total number of comparisons for the entire sort is approximately equivalent to n plus 2 into n by 2. That is, the array is divided into n by 2, 2 n by 2s, then 4 n by 4s, then 8 n by 8s, then n into n by n times. So, a total of m terms. So, it is n into m. M is nothing but log n into log n. So the time complexity is treated as order of n log n.